Hello, everyone. Welcome to RCR Wireless News's webinar on operators taking flight, the emerging role of drones in network operations and maintenance. I am your host, Susan Rambo, Senior Editor at RCR Wireless. Our panelist today is Lee Priest, CEO of ETAK. Lee has served as CEO of ETAK since November of 2011. His background includes 20 years experience in wireless and telecom. Lee has held various leadership positions at large companies and startups, including AT&T, Sprint, Black & Veatch, and eVoice, a small company sold to AOL in 2001. Lee earned an industrial engineering degree with honor from Georgia Tech and an MBA from Harvard Business School. Welcome, Lee.
Thank you, Susan.
The way today's webinar will work is I will talk briefly about RCR Wireless's new report on drones used in tower inspections, followed by Lee Priest, who will go into more detail about the state of the art of how drones are used and how data is collected. We should have some time at the end to answer questions, so please enter your questions in the question box. We will try to get to all of them as much as we can. A copy of this webinar will be posted with the slides to our website shortly after the show. So just a bit about RCR Wireless News. We've been covering the wireless communications industry since the early 80s. We inform our industry readers with breaking news, enlightened features, and invaluable insights, such as today's webinar on drones and telecom. So, operators and drones. So the main use for drones in telecom are tower inspections. And there are some new developments there. AT&T's been live streaming their tower inspections by drone. They've been working with some vendors to create their own tower inspection process using a live video feed to a technician at a desktop who can ask the drone pilot for more images in real time. This system will be rolled out soon to their drone inspection vendors. And then Verizon's been doing some acquisitions and investments in drone companies. They invested in the end-to-end drone inspection services company, Precision Hawk, a company that bought Drone.io, which has a list of drone pilots and is a popular portal for drone pilots to find work. Verizon also purchased Skyward, which is one of the FAA-approved LANC portals. The FAA's low-altitude authorization and notification capability, which is LANC, is where pilots will be going to post their flight plans to the FAA and get permission to fly in certain controlled airspace, like areas around airports. Also, extending networks for events and disasters is another telecom use of the drone. You probably know carriers have been using drones known as flying cell on wings or flying cows to restore coverage to disaster areas such as AT&T's work in Puerto Rico after Hurricane Marie. Their flying cow drones are now kind of part of the FirstNet system for first responders. Another thing that's happening, software for drone flights is undergoing a lot of innovation with automating flight plans, creating 3D maps for towers, and dealing with data sets. So many companies are working on software that captures and maps towers in 3D and are finding ways to deal with the data sets that can help carriers and tower owners scale up the inspections. AT&T alone has 65,000 towers. Another concept is to use towers as a backbone and that concept is gaining speed. The towers can be landing places for commercial drones. And the tower will likely be a place where drones rest or refuel if and when there's a commercial drone superhighway. Also, impromptu networks of flying cows that improve coverage could be based on towers. So just some key takeaways from our recent report. Just use of drones in tower inspections, is cost effective, provides valuable data, and saves lives. In the US, the industry has what it needs with limited red tape. Automation is coming to drone inspections. Stakeholders in the industry favor the UTM, which is the traffic management system for drones, and consolidation in the drone industry is on its way. So that's what our report found. And so make sure you get a chance to take a look at the report online. You'll get a link after the webinar. But without further delay, I'll turn it over to Lee Priest to describe what's happening in drone tower inspections. So take it away, Lee.
Well, thank you, Susan, and I appreciate you and RCR Wireless having me here today. I wanted to give everyone an overview of what we're seeing in the wireless industry with drones, and also look at the future where things are heading, at least where we think they're heading. And we've had the opportunity, we'll go through this, but we've had the opportunity to work with quite a few carriers and tower owners. So we think we have a pretty good view of what's happening, but there definitely could be more out there. So if you go from the title slide to the next slide, Susan, thank you. So in terms of regulations, and thank goodness for this, but we really are seeing them streamlined more and more for commercial drone use, certainly in our industry, but also in others. But speaking specifically about wireless, it's interesting. We've been working on drone technology for about 3 to 5 years. About 3.5 years ago, we had one of our technicians that we were going to have go through drone pilot training. And at the time, we actually sent him to balloon school, believe it or not. So he ended up being a balloon pilot, a certified balloon pilot, so he could get a pilot's license. It was one of the lower level ones, but that's what was required to fly a drone. So it really didn't fit with the skill set needed to fly a drone effectively. And so what you've seen now is the FAA has instituted a much faster, less expensive process for a drone pilot license. There's a series of classes, and I believe, and it keeps changing, but I believe most of them are online now, and a large number of hours that you have to get some flight training. But then but it's actually with a drone, and then you can become a commercial drone pilot. So I think they've got the right series of gates in place, but it's a lot cheaper than it was and a lot quicker. So you can get some folks up to speed, if you're in the industry and you'd like them to be able to fly. And so I think overall what we're seeing, the FAA really is embracing the technology. That's something that they were slow to do 3 to 5 years ago, but now they're getting the right committees in place, and they're actually encouraging quite a few committees within industries, which is helping. I know Nate has a committee in our industry and some others. And so there have been a lot of new proposals for regulations, which will help enhance the further usage of drones. So in terms of pricing, this is a question that comes up, and I think it's an important one for the industry. What are drone services priced like? Well, I think I should start off by saying the successful companies in our industry are really watching their costs. And the reason for that is, everyone is trying to deploy, the carriers and the tower owners are trying to deploy either towers or their networks as efficiently as possible. And they're not really willing to pay for an audit or any type of information that they get from a drone at a price point that's more than what they pay to have a tower climber give them the same information or close to the same information. So even though this is a new technology, the price actually has to be lowered. It can't even be at parity with a tower climb, unless it's providing a lot more information. And so that's been our approach, is we take a look at what a tower climb is. So for example, if to do a pre-installation audit, it's $800 for a climb, or maybe it's $450 for someone just to go out and use a pair of binoculars. You either have to provide a significant uplift on the information, or it has to be lower priced. And we've seen some competitors come and go over the past 3 years because their model focused more on the product than it did on the cost. And it's really a blend. That's what the carriers and the tower owners are looking for. And in terms of types of drones used, we don't talk about, and probably other companies don't talk about the specific builds and models that they use. But I would like to reveal what we found and what we see others doing, is that there really are a variety of brands, from models that are $1,000 up to $25,000 today. In the early stages of the industry, we saw some folks buying $100,000 drones with LiDAR units on them. Very expensive. You don't see much of that today, but it's really kind of that $1,000 on up. I think the majority, probably 80% of the drones used, are in the $1,000 to $5,000 range. And so that's a pretty low CapEx. It's not a huge investment to get started there. In terms of what these drones can accomplish, some of them are more video focused. So, I think all of them today pretty much have 4K video, but some have some pretty intensive video capabilities. And then others, for example, the drones that we fly, they're designed to optimize photos. And really most companies who are serious about operating in the industry today, they do customized stock models. I don't know of anyone that builds from the ground up. I mean, you can do that, but it's very expensive. It requires a tremendous amount of skill in putting those together. But you can get some stock models and do add-ons to them, and that certainly is done throughout the industry, and I think a quite effective model. All right, so the carriers, the big four, they all have drone flight policies in place. And this took several years to happen. Some were a little quicker than others, but they've all moved in that direction. And they all have pretty robust policies that, protect their assets and at the same time allow for flights near the towers. What we're finding, though, is they are engaging on different levels. So we have some carriers that are very interested in pre-construction audits. We've seen a lot of work there. That's actually the majority of our work, and that is going out and either doing photos or a three-dimensional model, and that's prior to construction. And generally, that's going to be on an existing tower. We see this more for macro towers. For small cells, those are usually so close to the ground that you don't necessarily need a drone to assist with that. But there's a lot of work also on water towers. There's not a tremendous number of water towers out there, but they are difficult to get your arms around unless you have a drone. So that work has, I think, been very beneficial to the carriers. Susan, you alluded to this. It's also the closeout packages. I know that you mentioned AT&T is doing that. My understanding is they're doing it not only with drones, but there's also tower climbers that are up there with a video camera in their hands, and they're live streaming that. So that's certainly a big advantage. That what I would consider in that same category would be quality audits. So it's very quick after a tower installation is complete for someone to go behind, independent contractor or a third party, and to send up a drone to check on the connections and the quality of the install. It's very effective. And we even do that. We have a tower division, and we will do that behind our own tower crews to ensure quality is up to snuff. And then finally, one very exciting area that I'll talk more about later, and that's drone air traffic control. There are a lot of things that are going on in the drone world that are outside of the wireless industry, but I think ultimately they will all impact the wireless industry because we've done a lot of testing, and we haven't found a better network for drone air traffic control than what the big four have today. Their terrestrial networks are huge. They have ubiquitous coverage. Any vacant spots they have are in a desert or a remote area that probably has little population. So there's a lot of opportunity for the wireless carriers to add drones essentially as customers on their networks. And then finally, for the carriers, 3D modeling. This is where they've been a little bit slow to engage. I think they see the value. We especially see that from their engineers who are building the networks. If they have to put together a new add to a site, whether it's the new antennas or remote radio heads, whatever they're adding, if they can get that three-dimensional model and see everything that's on the tower and certainly anything that's on their rad center, it's a huge advantage for them. Right now, they're primarily limited to either drawings, which are usually out of date, or photos, and those can be out of date as well, just depending on when they were taken. So, but the engagement with the 3D model, it hasn't quite hit yet with the carriers, but it's definitely getting there. What we're finding is they're more interested in some of the data that we can give them from a 3D model than actually using the 3D model themselves. So actually, if you move to the next page, I'll talk about the tower owners, and then I'll spend more time on 3D modeling in a second. And then in terms of tower owners, because they're the other huge customer in this industry, they've been slow to engage. We see some of them taking it in-house. There's a couple that are doing that. They've made a decision to take the drone work that could be done by a vendor, and I think they see a crossover with their current technicians that are visiting the towers. And in some cases, I think it's an enhancement for their technicians. Instead of using binoculars to check on the cell sites, they can use the drones and get closer in photos. And some are even interested in building their own models going forward. And you might ask, well, oh, actually, can you go back? I'm sorry, I was going to finish up on that one. So you might ask, well, what? Any other reason that they're slow to engage? Well, the tower owners, and it's probably a good reason they've been slow, they're focused on their growth. The industry is really moving and has been for the tower owners for quite some time here, and it's really starting to ramp up. So they've got their resources focused on getting more antennas on the towers. It's greater revenue for them, and it's also helpful to the industry as a whole. So I think we understand why they haven't been as quick to engage. But what I do think is they are missing a big opportunity here to improve their efficiencies using 3D models. But we have met with multiple tower owners, and when you get down to the worker level, the engineers and folks in real estate and planning, what you find is most of them are working off thumbnail photo databases. And I talked to one woman at a large carrier, and she said she spends hours, she was in the real estate department, she spends hours going through those thumbnails because she can't tell. In one case, she couldn't tell where the generator was. So she went through 55 photo thumbnails trying to find the generator until she finally found it. And once she found it, there was only one photo. Not very helpful. But the beauty, and I'll show you this in a slide in a minute, the beauty of the 3D models is you can click on a point in that model, and all the photos that help build it will pop up. So you could just click on the generator. We showed her that technology, and she just told us this would save me hours per day. So I think the benefit here is when tower owners start to engage, with the same staffing levels, they could probably do 2 or 3 times the amount of throughput on getting folks on their towers. So any backup or backlog they have could probably be cleared very quickly. So I think it's a huge advantage for them. So specifically on 3D modeling, so how do you build it? What does it look like? Well, there's a couple different processes. The one that we use, we find it to be extremely effective and very, very efficient and quick to develop. It's called photogrammetry. And essentially what we do is we take a drone and we fly it in a candy cane type of flight pattern around a tower. So you essentially circle a tower and move up or move down. And we take photos at points along that route. When we take those photos, there's a GPS coordinate embedded in each photo. So it tells us precisely where that photo was taken. And then we take all those photos, we get them, into our software, and that software stitches the photos together and develops 3-dimensional models. And those models are also called point clouds. So if you hear of photogrammetry and someone talks about 3D modeling, it's essentially a point cloud. The reason for a point cloud is it's very flexible. You can do a lot of things with it. You can create a CAD drawing. You can just work with the point cloud itself. If you go to the next page here, so this is page 7 here. This is a representation of how we fly a tower. It's not precisely what we do, but I think it gives you a good idea. You take the drone up from the ground, you circle it around the tower in various points. Excuse me. And then after you do that, you take these photos, or while you're doing that, you take these photos. And if you want more resolution, you can use a high resolution camera and get closer in, or the customer may want to look at the compound and the surrounding area in the 3D model. And so in that case, you would actually fly a little further out. So it just depends on how the customer, whatever the requirement is. So next slide, please. Excuse me. So on the left here on page 8, you have a photo, and that's one of many photos we took from a drone on this particular 3-dimensional model. On the right, you have the point cloud model. And you can see it's a little pixelated there. Well, the reason for that is the 3D model is built of millions of points, and that's where the word or term point cloud comes in. And if you click on any one of those points, all the photos that helped build that will come up. Any one point would have between 10 to 40 photos, just depending on how it was built. Excuse me. Next slide, please. So this is a good example. Right in the middle of page 9 here, that's a three-dimensional model. You can zoom in on that, you can spin around, you can go down to the shelter, you can go up to the top of the tower, you can actually move inside of a rad center and look at any of the cabling you'd like. If you look up at the top of the tower there, there's a small point, that's where we clicked, where the top of the green line. And that's showing you the photos that help to build that particular element of this three-dimensional model. In addition, that green line, the reason for it being there is we measured from the center line of the top rad center down to the ground. Excuse me, my throat's a little dry. 1 second. So we measured from the center line down to the ground. That's exactly 164 feet, 6.84 inches. That measurement is more accurate than a tape drop. And that's not our saying it, that's the customer telling us that. So it's a very accurate way to measure antennas, cabling, the height of a tower or rad center. What we're also finding is some carriers are asking us when they're going to put a new set of antennas on a tower, well, what should the length of my cabling be? And of course, it still has to go into the shelter, but you can get, plus or minus 10, 20 feet, and that can either save them cabling or it could save them the issue of ordering too short of cabling. So it helps speed the installations and helps avoid material cost. Okay, next slide, please. Okay, so switching gears back to drone air traffic control. I think Susan mentioned this in the beginning. She didn't, this is something we're seeing with the carriers today. They're currently working with NASA and Qualcomm. Different carriers are. And they're trying to determine what is the best way to develop this air traffic control system. One of the objectives, obviously, is to make sure the wireless, excuse me, the terrestrial wireless system will be effective. We believe, based on our testing, that it will. Their testing is probably, more extensive. But this is the opportunity I mentioned earlier to add drones as customers. And it's very important. I don't think anyone knows if we're going to have hundreds of thousands of drones in the air or millions or even more than that. But the fact of the matter is, these are additional customers that they can put on the network, and something, of course, all carriers are interested in. The one thing to mention, I think it's very important about a drone air traffic control network, the reason this hasn't developed overnight, it is extremely complex. There are a lot of components to this. We've actually, at ETAK, we've filed, I believe this morning, we actually filed our 16th patent on drone air traffic control. And we think it's an area that's going to just blossom tremendously in the future. Collision avoidance, if you think about these drones flying at 35 miles an hour down, an area of the country, what's in front of them? Is there another drone? Excuse me. Is there another drone coming head on? How do you log that and manage all that traffic? Especially as you get into hundreds of thousands of drones traveling in the airspace. Flying lane management, where are those lanes? And then, what's the separation between drones as you fly? These are all components of our current air traffic control network with jetliners, and it's something that has to be considered and developed for drones. And then just finally, just a quick overview of ETAK. As Susan mentioned, we've been in business for 20 years. We do perform ground and tower work. That's our core business. But we are seeing an incredible growth rate. Last year, our drone business grew over 700%. We consider ourselves to be a leader in the industry. Excuse me. We've talked to customers, and based on the thousands of paid flights that we've done, that we believe that to be the case. And I mentioned the patents. We do have 10 secured, and then we have an additional 40 that have been filed. So we have 50 in process. Excuse me, sorry.
Take your time.
No, that's it.
That's it? Okay. Yeah. Well, that's very interesting. Thank you for that overview. And now it's time to go through some questions. I see that we have quite a few in the question box, and I want to encourage other readers or listeners to drop your questions into the box. Yeah, it's a fascinating subject. A lot's happening right now in this space. I was wondering, so I'll start asking some questions. Could you, Lee, talk about the data that you give to clients? What files do they get? And how do they incorporate that into their databases?
So that's a very good question, Susan. I think that was one of our struggles early on with the 3D modeling, is matching up the files that we've been providing with the customer's databases, because they have some very effective databases, but they weren't designed to receive and utilize point clouds. So what we're moving to, and what we're finding to be the most effective, it's really a web-based model where we post the point clouds to the web in a secure format, secure site, and then those can be accessed, via browsers by the customers, and they can still, move around within the model and measure within the model, and then access all the data that they're looking for. I think there's a couple. We have, obviously competitors out there. Some folks like to host that on their own servers. We're pretty agnostic. We'll host it, or we'll let the customer host it. But that appears to be the best route to go, to make it just more of a web-based type of environment.
Mm-hmm. And so one of the listeners asks, what is the cost of software that develops the 3D model?
Well, there's quite a few packages out there, so that's a choice to be made. The author of the software, the manufacturer of the software, but it varies. Some packages are on a monthly basis, and you could do it for a couple $100 a month. Some want to charge thousands per month, which, that's a little high, especially if someone's just trying to get involved in this technology. Yeah. And there's a few that you can buy outright. They're very expensive. I'd say in the 10,000 plus range and even higher. So, my recommendation, if someone's going that route, is more do it. Most of them have monthly trials you can do for free. And then if it works, you move from there to, maybe 1 or 2 users, a couple $100 a month. That can be pretty effective.
William asks if there's a product that allows you to see remotely live video or 3D model and remotely command where to focus.
Well, there are products for remote live video viewing. Right now today, there's really not, the ability for someone to control a drone off site that I think people would allow to be unleashed. So, for example, my company, we would not want to allow a customer to move the drone. We prefer for them to give us an instruction, and we have someone on site who would actually, take the drone and put it in a different location to get a different view. Can it technically be accomplished today? Absolutely, that can be done. The remote flying of a drone, it is. We find that to be something that is a safety concern, because around towers, it's a very tight area. We try and keep ourselves as far from a tower as possible, but if you're within 25 feet, 30 feet, and someone else is flying remotely, they may not see something in the way, or they could make an error. It's just much safer to have someone on site. So that's how we approach it.
Okay, here's some, so is the altitude also recorded along the coordinates in the 3D model?
Yes, what happens is the GPS coordinates essentially, you can get the altitude, but the altitude is also an element of that. So yes, we know the altitude. You essentially, and just real quick, you have a reference point, which is, the takeoff point for the drone is essentially ground zero, that GPS coordinate, and then it measures from there up to the point, where it takes an altitude measurement. And so the difference between those GPS coordinates is essentially the altitude. Now that's the relative altitude to that area. It may not be the actual altitude from, mean sea level.
Mm-hmm. Do you know if the FAA is accepting drone-based measurements for tower measurements?
If they're accepting, if the FAA is drone-based,
yeah.
Oh, probably for the tower height is probably okay. I think I get the question. I don't know. I would imagine yes, because essentially it's there might be a technicality there because sometimes government regulations lag. So I don't know the exact answer to that, but we can find out.
Okay. Can you talk about some of the big gotchas in drone inspections of telecom towers that the drone industry has discovered over the years?
Well, yes. I think, you have a couple of things. The first is, and this is going to sound really simple, but so the higher megapixel camera, the better, because you just get more crisp shots and it's easier to zoom in. And that one is, is something that was a big gotcha in the beginning a couple of years ago, because the original drones flew, I think, with probably 12 megapixels or less, and now they're much higher, which it helps quite a bit. And you can always customize, and we've done this. You can customize with a high megapixel camera, but then sometimes the shutter speed isn't what you need. It may not have automatic picture taking capabilities. So it's really, it comes down to the capabilities of the camera, especially for the work we do. And I think what we see is the need for carriers and tower owners. Really today, anybody can do a video of a tower, and it's quite honestly not that interesting. We do videos. Sometimes tower owners would like to see the access road. We'll video that in, and it's a necessary component of a package they're looking for. But it's really not that sophisticated. The video is more for movie making. That's where it's optimized for, and that's the industry that utilizes it. But we're really interested in the cameras. Packing more and more megapixels into that camera so you can get crisper and better photos, and it enhances that three-dimensional model significantly. Now, there are several gotchas in the 3D modeling process. I'm not going to talk about those because I think we have about 30 patents filed on them because they were so hard to figure out. We wanted to protect it. But the 3D modeling is, it took a while to get there, and other people have different approaches. I think some of them are effective as well. But that would be my answer to that question.
Okay, thanks. That's good. Along the lines of the camera the cameras, what is the accuracy? This is Christopher's asking this. What is the accuracy of drone-based tower measurements using, for instance, a 4K camera?
Well, I'm going to answer that a little bit different. I would, say it has more to do with the number of photos that are taken when you build the three-dimensional model and the megapixels, because a 4K camera that's more a component of video. If I were to say 16 megapixel camera or better, and you're taking at least 300 photos, 180-foot tower, something like that, we are measuring with accuracy down to 1 centimeter or less. So it's very good. I think for the carriers, that's more than effective. For the tower owners, sometimes they want even better than that because they're looking to measure actual nuts and bolts. Is that 5/8 or is that, what's the measurement there? But it's getting better. I think last year, we were at 2 centimeters. Now it's less than 1. So we'll probably be down to a nit here in the next 12 months. So it keeps improving.
Great. So there's two questions about signal. So Barry asks, can you talk about conducting signal tests and what type of drones have the ability to analyze interference received by the tower? And then another question asks, that Marco cell towers emit significant RF energy, which could interfere with communication to the drone. Have you experienced any issues like this? And what do you do to prevent it? So two kind of related.
Okay.
Somewhat.
Yeah, no, I think they're both very good questions. The first one, we really haven't seen much interest from carriers on the interference piece. I think that the problem with interference is when it's bad, it's really bad. And the carriers not only want, but they need to get that fixed. But it just doesn't, for us, we don't get that request very often. So we've really, and we probably would just, ask them to find another vendor. There's just, just in terms of on our business side, we have to have multiple projects to stay in business. So I would have to pass. I don't know the answer to that one. I know that there are people that have worked on that. I think that they've probably done an effective job. I just, we talked to someone in the past, 2 years ago. I just don't know where they are on it today. In terms of RF interference, it's a great question because that was something that everyone was really frightened about, 3 or 4 years ago. Are you going to take a drone up in front of an antenna and that, the RF signal is just going to just completely eliminate your communication to the drone and is it going to, fly into the tower or fly off? Well, we found that it's really negligible. We don't see any interference. There's two communications. One is the actual communication from the controls to the drone, and that's a different feed than the drone video. That's the drone video is usually over Wi-Fi back to the handset where you're controlling, so you can actually see what you're doing up there. Sometimes we see a little bit of jitter on the video feed that's going over Wi-Fi, but we have never experienced a problem controlling a drone near a tower, no matter how close or how far from it. The RF, whether it's in front of microwaves or in front of antennas, it has not impacted that communication. So.
That's good. That's good. What's that?
Just real quick on that, Susan, I would say that the one thing from a safety perspective that we have looked out for, and then there are particular brands of drones we don't use anymore because, we might have had a rotor problem. So if you have a 4-rotor drone going up and one of those rotors has a problem, the whole drone has a problem. That's not a good situation. That's been more of the issue we've had to move out, of our business, just, get rid of those manufacturers who tend to have recurrent problems. But the RF component has not been an issue.
Okay, that's great. A couple people are asking about insurance. Are you aware of any challenges in terms of insurance coverage for a new business of this kind?
Well, that's another area that's matured. So there are products out there for drone insurance. The one challenge you have is most of the companies that set the limits that you have to have in place, they turn to their aviation departments. Well, their aviation departments are usually flying jets, private jets for the CEO and the C-levels of that company. And right off the bat, a couple of years ago, they said, yeah, you need $5 million in insurance, which that might match up with an actual aircraft, but for a drone, that doesn't really make a lot of sense. You're flying a small piece of plastic that's maybe a couple pounds. It's not going to create, a problem that requires that level of insurance. So it's about, 1 million or 2 million is required depending on the carrier or the tower today. We do what they say. We put it in place. I think it's probably higher than it needs to be, but if they require it, we'll do it. So that's a big challenge. That's probably one of the biggest barriers for folks to enter in. The customer relationship obviously is a big and important element, but the drone insurance is not cheap. Any insurance that's $1 million or 2 million a year, it's going to cost some money.
Yeah. There are a couple, you're really on the hot seat today here. There are quite a few questions, so I'm just going to try and move through them. There are a couple questions about weather, and it kind of feeds into a question I had. So William asks how wind velocity factor determines the type of drone. And I'm also wondering, are you seeing any drones that really are kind of all-weather drones? Are there any weather drones that really work in all weather?
Oh yeah, there absolutely. Almost, I put it this way: we have not found a drone yet that does not work in all weather. You know, any of the ones that we use. You know, any of the ones we tested that failed other tests may not have been, but they never got to the point where we were testing them in snow and rain and other conditions. I'll tell you, the question about wind velocity is a good one, because you know the number one reason that we will not fly is if the wind is over a particular mile per hour, and you have to not only look at the ground, but you have to look at towards the top of the tower, because the wind does increase as you get higher up in the air. I would say roughly when you start to get over 25 miles an hour in winds, it can be just so challenging to keep the drone stable that you're concerned about it getting too close to the tower or potentially the trees near the tower, or it might even just be so unstable you're not getting good photos. So it's kind of a double whammy there. But the wind that's number one. We always check that, and there's certain times of the day that you can fly when it's less windy, and then really heavy rain is a problem, not so much for the drone, but you just can't see much. So then you go up, and the drones could be struggling in the rain just because it's having to deal with it, and then you're not getting good photos. So the perfect environment is a nice sunny day. Cloudy days you can still get good photos, but we do prefer a sunny day where it's not too windy. You can just get some really crisp photos of the tower.
Cool. Interesting. So how do you overcome some of the inherent inaccuracies in your GPS positioning? For services, are you running differential receivers with a ground station?
That's another good question. We use ground control points, and we have our own particular process for doing that. And so we look at it more of GPS is highly accurate if you have the right reference point. So we use our initial reference point, and then we keep that consistent throughout any photos we take. And then that allows us to have a system of measured GPS coordinates that all correspond accurately to each other. And that's what ensures our model, when we put together those photos. For example, it could be from different flights, because some drones will have a 30-minute flight time, some will have 20. And then, you've got to potentially do multiple flights to get the right number of photos, the right angles, and those all have to be put together into a three-dimensional model. So I think it's a great question, Susan. Ground control points are very important, and GPS can be inaccurate if you use the wrong reference point. But if you use the right one, it's a huge advantage in building these models.
Cool. And Robert asks, who owns the data you capture with your drone?
Well, it depends. Usually it's typical in any type of a contract. If we're contracted by a company, company A, to go capture data, then they own that data. And it's pretty straightforward. And we have contracts with folks, and those contracts outline data ownership.
Okay. Here's a question. How are you defining edges in point clouds for CAD drawings?
I don't know the answer to that. I'll have to ask my engineers. That's they work on this daily, and they would be able to take a crack at that one.
Right. Yeah. Let's see. So, what is your opinion of NASA's UTM, the UAV traffic management system? Being worked on by industry and government.
Well, I think overall it's a great thing. What we learned over our work on air traffic control technologies, and it was actually news to me, but NASA is very involved in some of the development of the FAA's policies and procedures, and some very sharp people there. I think that what they're experiencing right now is just a unique challenge. And how do you? Drones are a whole new environment. You take out some of the issues. What a lot of people don't realize is most problems with regular airplanes, when they have issues, it's usually pilot error. And so with drones, you should take that out of the equation because it's an automated path. But then some of the issues, you're trying to avoid accidents that happened, with jet airliners or just planes in general, even small planes. They help you identify how do you build this network to avoid any problems. The real objective is we have to prioritize the safe operation of drones in the nation's airspace. That's of paramount importance. And if we can achieve that, I think what you're going to see are drones delivering products, primarily to metro and potentially rural locations. The cities are tough because of the large buildings, but they may get around that. But I think it's, just the massive population in the metro areas. But then also, one of the huge potentials we have is flying drones that carry passengers. So, some people look at that and say, well, when's that going to happen? Well, the technology today is there to allow a drone to carry, at least one person, and to do that for up to, 40 to 50 miles. And the cost of those units in mass production is probably somewhere between $40,000 to $70,000. A new car today might cost $50K. So, you could see potentially families having one large SUV and then one commuter drone. And to get there, not only do you have to manufacture that particular, piece of equipment, but then also that's where NASA and the FAA comes in. And I believe there's really no doubt in my mind that the drone air traffic control will be done over the wireless networks, the terrestrial wireless networks. The satellite network has too much latency. It takes too much time to get up to a satellite and back. There's some other technologies that just aren't as ubiquitous as what the big four carriers have. So you'll see in our lifetime the flying car, and it will be either controlled or at least monitored and directed over that new drone air traffic control system.
So one of the viewers asks, for flight control in case of a high number of drone traffic control, what frequency will be selected going forward? Is that anything you would know now?
Oh no, I wouldn't even give a shot at that. I think that there are a lot of frequencies that are available that offer good opportunity for success. Some are better than others. Mm-hmm. But I think what you have is some extremely capable and far-reaching carriers that can assist the government with their networks being utilized. So that's probably some of the work that's being done in the interface that the carriers are having with NASA and Qualcomm to determine what is the best frequency.
Right. Yeah. Let's see, so quite a few questions. So a couple people are asking about, I think you may have answered some of this before, but they're asking about automated drone inspections. And so do you think that will happen with the UTM, where drones can just automatically fly around and on a set schedule, kind of autonomously, and inspect?
Oh, go ahead. I'm sorry.
Yeah, that was it. Yeah.
I think I interrupted you there when you're saying inspect towers. For towers, it's certainly not something that we're engaged in or we would recommend. I think where you're going to see that is on things like pipelines. So, oil and gas pipelines that are generally remote areas, they're cutting across large swaths of land. You can take a drone up at some height, I don't know, call it 40 feet, whatever's effective, 40, 80 feet, and it can get a good view of the entire pipeline, check for leaks, the likelihood of there being anything in its way is almost negligible. But the problem you have in a tower environment is it still is a tight space. You have the occasional cornfield out there where it's just a tower smack in the middle of the cornfield, but usually there's trees around it. There might be a neighborhood. Putting a drone in a box and having it pop up every now and then to go out and fly the tower, I think that might come eventually in certain areas, but there's just a lot of problems that can occur, and without someone on site, it's a danger.
Right. Yeah. Plus, I'm sure the weather. I mean, how would the weather affect any kind of automation?
Yeah, it could be a factor. Especially the wind.
Mm-hmm.
You would need to be measuring the wind up where you're going to fly, and so it's just I don't know that the advantage that it provides offsets the challenge in safety, and I think that's the real key with everything. One of the reasons the drone industry actually cracked into wireless is because there's no doubt in anyone's mind it's safer to take a drone up a tower than it is to send a tower climber. And it's just a necessity of the industry. People have to climb towers and do the work up there. They're still doing the bulk of the work, and that'll continue for a while. We and others are experimenting with putting robotics on drones to do that work over time. But that's still in its infancy. It's taking, I think, more time than we and others expected to make that work. Mm-hmm. But flying a drone without an operator on site right now, in the specific realm of a cellular tower, that's not something we would recommend or participate in right now.
But some people are automating their flights, like they have a flight plan, but I guess they always have, and the drone like automatically follows that plan, but it's always there's a person on site, right? Kind of watching it.
Yeah, we don't do that either, because if you enter in one wrong coordinate, you can move right into that tower. So we find that it can be effective. You just have to be very careful when you do it.
Right.
There are a lot of advantages to doing that, especially if you're taking video or pictures. You can do it precisely the same every time.
Right.
You might be a little smoother than flying. So there are advantages, but and you can also do that. You can do it laterally, as opposed to circling the tower. You can do it laterally, and it can be effective, and there's less danger. But automated flights, you have to enter in coordinates, and when you do that, if you miss a particular coordinate, then you could have a problem. So,
right. I guess, and that goes back to the question about insurance, right? If you hit the tower, there goes your.
Well, yeah. The odds of damaging a tower are very slight if you have a drone hit it, because the drone's just so light, and it's carbon fiber and plastic generally with some electronics. But that's not acceptable to carriers or tower owners. You can't touch their assets like that.
Yeah. Okay. So one person, I just want to answer this question. One person was asking what LANC stood for. And it is the FAA's low altitude authorization and notification capability. So it's LAANC, and it's, I don't know if you want to talk about that LANC and how are you guys using it, or do you need to use it?
I'm not as familiar with it. We do file NOTAMs before we fly. Mm-hmm. So we check with the FAA. We have to get approval from airports, the big ones and the small ones before we fly, depending on our proximity.
Yeah.
So we follow all the FAA procedures. I'm just not familiar with that term. Our pilots probably would be.
Yeah, I think it's something that's rolling out over, so it might not even be in your area yet, but it's rolling out over the country like this year. And it's just basically, it's a streamlined way to apply for an FAA approval to like fly by an airport or wherever, so.
Oh, gotcha. Okay.
Yeah. So So we have like 5 minutes. Maybe I'll try and, there are some people asking, again, about the price, like the price of the service.
Okay. Yeah. And let me take that one, Susan, because I think I might be able to help folks out there.
Okay.
You know, if that question is coming more from a customer potentially using it, I'll say this on our end. And I think other successful companies, we price this. It's going to be probably 1/2 to 2/3 the cost of someone climbing a tower.
Mm-hmm.
And we've gotten efficiencies with some large projects, and we found that provides a tremendous amount of value to the carriers, to the tower owners. And then it just depends on if they're looking for a quick audit. Some folks just need some photos. Some folks are looking for a 3D model. As you're talking about, just a little bit more for a 3D model. But I'd say that in general, you're for half the price of a tower climb, you're going to get better shots just because they're at different angles than either from someone on the ground or climbing a tower. And then probably for 2/3 the price of a tower climb, you're going to get a 3-dimensional model that you can measure within. You can keep it long term and use it to go back and reference later. It's a pretty impressive and incredible advantage for that, owning that for that particular tower or rad center.
Right. Great. So we do have, we still have more questions, but we're going to have to end it soon. So what people can do, if you do have questions, you can still load them into the question, and we'll end in like 5 minutes, but load them into the question box, and then Lee would be happy to answer them later. He can follow up with you later on that. But as our final question, what can we expect happening in the next 4 to 5 years?
I think that you'll see the 3D models really take off. I mean, we're starting to get rumblings that some folks are embracing that, especially on the tower side. Now that they've gotten over the hump, as I mentioned, of some of the growth. So I think that's going to become standardized throughout the industry within probably that 3 to 5 years. That'll just be a standard way to look at a tower, to measure within it, throughout all the carriers as well as the tower owners. I think you're going to see drones flying equipment up to tower climbers. We already have seen that with one particular incident. It wasn't a tower climber, someone was on a crane, and the crane had a problem, and then I guess the news crew had their drones, and they flew up some rappelling equipment, and the person rappelled down. So, there's no reason a drone can't fly up different pieces of equipment. It would be lighter at first, and then maybe heavier over time, up to tower climbers to assist them in their jobs. Yeah. So I think you'll see the beginning stages of drones doing work on towers. I mentioned that a couple years ago on one of these webinars, and it hasn't hit yet, but it is coming. And then, of course, the air traffic control, I think that'll be worked out in the next 3 to 5 years, and you're going to see drone deliveries. There are a lot of companies beyond Amazon that are interested in this. You look at Walgreens and CVS and many others. There are a lot of folks in the country that are interested in getting products quicker and cheaper as well. So that's my take on it.
Yeah, that's interesting. Well, on that note, I want to thank you, Lee, for the interesting commentary and for letting, kind of filling us in on what's happening in the industry. And I hope sometime we can do this again, because there's a lot to talk about. Yeah, I hope so. So thanks again, Lee.
Well, and thank you, Susan, for having me.
Yeah, and so we're out of time now, but your questions in the question box, we will deliver them to Lee Priest, and he will take a look at them and answer them later. So once again, I would like to thank our panelist, Lee Priest, CEO of ETAK, for your presentation and insightful comments. And thank you to the audience for submitting questions. The replay, slides, and report will be available on our rcrwireless.com site. This has been the RCR Wireless webinar on Operators Taking Flight, the emerging role of drones in network operations and maintenance. I've been your host, Susan Rambo. From all of us, thank you and goodbye.